Corporation, and they do a lot of research and data science, and they say they use math as a superpower, so I'm really excited about seeing how they do that. I'm going to turn it over to them and let them blow your mind. Okay?
All right. I'm Denise, by the way. This is Kayley. Heather's our CEO, and she's an amazing person. She's but she is a data scientist, and she's the one who started up this company in 2011. She had $236 for this company. It's a Virginia corporation. It's not venture capital funded, which means we don't answer to anybody. We don't have to prove anything at the end of the day that we did this. Now, we have some grant money, so that may be a situation with just the grant money that we have to say, yes, we did this project. But we're already in the revenue in tens of millions annually already. Okay, so Liz, who are you? Well, I think she meant who are us. I'm not sure. But we're data junkies, we're engineers and mathematicians. We have people who deal with purely the IT side of the situation. We have people who purely just deal with the math. We're innovators, we're scientists and researchers, and we have a Save the World complex. So these are some of the types of things we do, as well as, I believe, a couple of job titles. So yeah, we have a lot of guys that are involved in our network engineering, cloud storage systems. We have a large cluster in AWS that we're running for some neat stuff, and so we have the Internet of Things sensor collection is that the one we're using for the weather? Or is that different? That's different. Oh, sorry. All right, so I'm doing the machine learning and applications of AI as part of what I do. It's not all of it, but part of it. And we belong to, so these are several offshoots of effect. And it's effect, as in the butterfly effect, if anyone's wondering. It gets kind of confusing because it is a play on words. But we're part of the Strange Labs. And we're always hiring experts and innovators. We have several young people, a couple of interns. Our social media director here is, are you still you're in college, right?
I'm going to be going to trade school.
Oh, okay.
In October.
So, but she just, we freshly got her out of high school. And her name is Kayley. I don't want to discount you.
You're good.
And so we have a lot of internships, both full and part-time. We're looking at possibly in the summers having a boot camp, which would give people an introduction to the company as well as learn maybe something you don't know and you would be interested in. We have a host of hackathons, we host seminars and meetups, and if you have a passionate project, we may be able to fund it. So we're a stable, rapidly expanding company. We work with industry experts. Let's see. We help to solve critical real-world problems, which is exactly true. I have yet to work on something that isn't a real-world problem. So yes, we do have amazing benefits, and yes, trust me, yes, I went from $100 for a doctor visit down to $5. It's pretty nice. So, all right, so Effect is an R&D effort for Strange Labs focused on researching real-world global humanitarian problems. And the world's greatest evil, how Strange
Labs is helping to detect, monitor, and eradicate human trafficking networks, which is going to be the big thing that we talk about today, is how what we both do, which is completely different from each other, how it helps us try to track down those human trafficking networks and what we get to do with it. So, first off, we're part of the Strange Labs, so it's a project of Effect, the Strange Labs. And so, this background actually is our advertisement. Of course, it's like all cut off, you can't see it really, but it's a comic book and it has Strange Labs. Then we have the Dr. Nerd Herder right here, and then the CEO is right here talking to him about how we need to start rounding up a bunch of nerds. We just were able to start bringing in younger people. So I'm only 25. I graduated college not too long ago. And so just recently, we've begun getting funding to bring in people like myself or yourself and start growing the company a little bit more. So she told you I'm Kayley. This is my superhero. I am the manipulator. I'm a junior data scientist, and I thought I went to a small college until I looked up your guys' student population. So my college was like 10,000 people, and apparently you guys have less than 4. So that's kind of crazy. Whew, I didn't go to a small college. I have my degree in applied mathematics and actuarial science, a minor in finance, and a certificate in risk management and insurance, which is a novel of a degree, and I don't do anything with it at this point, really. So I was a financial advisor with Edward Jones. Absolutely despicable. Didn't like it. Knocked on doors for like 9 o'clock in the morning until 9 o'clock at night. Hi, my name's Kayley. I work for Edward Jones. Would you like to invest your money with me? Blah, blah, blah. Not fun. Not fun. If you want to write down our email addresses, we have a lot of information for you guys at the end that's like really actually important. And you can email any of us if you have any questions. But,
Alright, so this is me, I'm Denise. I'm the digital doom whisperer. It's a long story, but I can walk up to a computer, not mean to touch it, it breaks. So we've decided that's my superpower as well as my kryptonite, because when it happens to my own equipment, it's annoying. So I went to Stetson University, which is about the same size as this school is. So I was excited to hear that I'm not going to a university like George Mason, where I got my master's, which was huge. I got lost almost every day, and I've been going there for 3 years. So I have a bachelor's in finance, an associate's in IT, and a master's in applied IT. My previous career was in the accounting field, doing accounts payable, fiscal assistant, which is budgets and helping set up for meetings. And anyway, so we all have our own comic book character being drawn, and if you guys come with us, you get your own character too, so keep that in mind that you may want to know what your character is.
alright, so everybody's been really quiet so far, except for this lovely gentleman that we met before the actual presentation. So all I ask is that you guys chime in at least a little bit. I don't care if you whisper it, actually say it, shout it, scream at me, I don't care. But just don't leave me hanging up here asking you questions and having to make up answers on my own, because then it's not as fun, at least not for me. So we want to get you guys warmed up a little bit, get you thinking about what are some different careers you guys can go into with a math degree. Anybody? Teaching? Teaching? Anything else?
Actuarial science, I guess.
Okay.
Consulting?
Consulting? Okay. Like tutoring or?
No, just like business consulting. You can work within a company that looks at another company's like data.
Kind of like analytics?
Yeah.
Do some data analytics? Alright, I like it, I like it. Anybody else? Lovely gentleman in the back, do you have any ideas what you want to do?
Like quantitative analysts.
Okay, awesome. I like your dreams, dudes. Alright, so do you guys feel limited because it seemed like it was like pulling your teeth out to get those answers? So we got teaching, we got data analytics, we got awesome quantum analytics. Do you guys feel like you don't really have a whole lot of options or just scared to talk?
I feel more like it's choice paralysis,
Okay.
because there's so many things you can do.
Okay.
But, because there's no, everything, well not everything, some would argue everything worth doing, but almost everything has some sort of quantitative underpinnings, so you can apply the things that you learn in math to so many different fields. I have no idea which one I would want to go into at this point. But
Absolutely, you're totally right. Some people feel like their family pressures them into doing certain things, like say your dad's a doctor and he's like, well, you're gonna grow up and be a doctor. So you'll hear Denise's story about how she felt like she was pressured. Myself, I started as a pharmacy major, did a semester of it, realized that was not gonna work for me, and I was good at math, so then I just kind of jumped into it and I didn't know what I was gonna do. And since it was a smaller college, I didn't have a whole lot of options when it came to math. We just kind of have the broad applied mathematics. But we want to know if you guys want to make a positive impact in the world. Your quantum analysis, now man, that's going to make an impact. And so like, do you guys want to make an impact? Is teaching going to make an impact on your students, or did you want to think bigger, make an impact on the world as a whole? What are you thinking? Students. Students? Okay. So then, what are some humanitarian things that you can think of? So like, we told you human trafficking is going to be the big thing we talked to you guys about today. What are some other human trafficking things? What are other humanitarian things that you guys can think of that you might use math or technology for?
Food.
Food?
Like figuring out how much food needs to go in certain places for them to survive.
Okay, that's good. I like it. Anybody else? Anybody back there that is hiding and doesn't want to work? No? You have anything?
Me?
Yeah, humanitarian problem that you think?
Drugs transportation.
Okay. All right. Sure thing. All right. So my big thing that I personally work with is cryptocurrencies. Does anybody know about Bitcoin? 2, 3, 4. Well, that's more than I thought we were going to say anything. So for those of you who don't, I'm just going to talk very high level about it, which might be a little bit more difficult for me than it is you because I really like this stuff. So I really want to tell you a lot about it, but you don't need to know a lot about it for me to explain what I do. But right now, Bitcoin, it is a digital token worth, when I first started this, it was worth $4,500. And then this morning, when I sent this presentation, it was worth $3,768.69 a coin. And as of right now, it's worth $4,014.27 a coin. So what is it, really? It's a digital currency that was created by a group or a guy. They called themselves Satoshi Nakamoto. Nobody to this day knows who it is. If they do, they haven't said anything. When he created it in 2009, he created it to be open source, so he could just leave it. And then people could take over and work on it themselves. So you gotta wonder, how do you get Bitcoin? And I had no clue what this was before March. So I really was like, how do I even get this digital currency that's just out there, just exists? So there's people called Bitcoin miners, and what they do is they offer up their computing power, and they solve computational math problems that are extremely hard. A regular computer can't even do it anymore. They've upgraded at least 10 times to different technologies, and now they have giant buildings that are running these networks to mine these coins. You can buy it from somebody who's mined it. Not as easy to find. Or you can go on something that's a cryptocurrency platform, kind of what I just opened on my phone. And this is called Coinbase. So it shows me what it's worth, what I can buy it for, how much I can sell it for, and it has some other currencies on there that you can buy as well. So that's how you get it. But why would this be good for human traffickers? Anybody know? Any idea? What do you think?
It's supposedly anonymous.
Supposedly anonymous. Yes. So obviously it says anonymous. No. Bitcoin is not anonymous. It's actually very, very public. So I went online to buy some hair color the other day. Actually last night. So it was kind of fun. And I went to go check out, and it said, pay with Bitcoin. Oh my gosh, nothing has pay with Bitcoin. So I was super excited, and then I realized I don't own enough Bitcoin to pay for it. So there's 6 major merchants that actually sell things with Bitcoin. And so like Dell, you can buy a computer with Bitcoin. Overstock, if you want to decorate your dormer, you can buy it with Bitcoin. Microsoft, you could buy Office with it. PayPal, you could pay into it and get your taxes done with Bitcoin. And or Dish Network. Dish accepts Bitcoin, which is pretty crazy. So other than those 6 majors, there's a lot of minor things like that random hair color place that accepted Bitcoin. But most people use it on the dark web. And I have Silk Road here because I'm going to tell you more of a story about a onion site, a hidden wiki site called Silk Road that's been taken down, and how they tracked it, and why that works out with us, and how we would track down human trackers. Got a question? What's up?
So in the background of this slide is binary numbers.
Yes.
So do they use those binary numbers to measure the value of the Bitcoins?
So they don't use binary to measure the value of Bitcoins, but they do definitely use it in the background, in the coding and things like that. So that's the stuff I'm not getting deep into, the coding and whatnot, but I like your thoughts. So like I mentioned, it is open source. So Satoshi Nakamoto put all the coding out there and then said, whoever wants to take it over can take it over. So now you can create alternate coins off of the Bitcoin network. So I can make a Kayley coin. Not that it's going to have a great network of people to spend it, but I can do it. There's Ether, Litecoin. There was something called Dogecoin that had like this cute dog that smiled, and then somebody robbed all my money. So not so cool anymore. But everything
They had a
is,
mascot.
yeah, it was millions and millions of dollars, and they just wiped it out. So they got in trouble, they're in jail. It worked out okay, I guess. Not the people who had money in there. But the reason that it is not anonymous is because everything is recorded on a digital ledger called the blockchain. So this blockchain is really, really cool. So it's decentralized. So the first picture shows you all the different nodes, and none of them have like a central point that they go to. And this one over here shows you more like the bank. So if this was me and I was going to send money to you, I have to go to the bank to send you that money. Whereas if it's Bitcoin, I can send it directly to you, and there's no middleman. There's no regulation. The government doesn't keep track of it. They want to, but it's not happening. So it's really fast. You can send money to Mexico in seconds. So if you had family back in, say, Mexico, and you wanted to send them money that you've earned and help your family back home, I can't remember what that's called. Sending money back home to your family?
Do you want to wire it?
No. Anyways, you can send it in seconds and not get charged a bunch of money, whereas if you went to the bank and you wanted to send money to Mexico, they're going to charge you anywhere from 10 to 30% of that money to send it. And so this is a much cheaper, affordable, direct way of sending that money back. It is updated every 10 minutes. So each one of those nodes has a full copy of the blockchain. It is over 450,000 blocks at this point. I started downloading it at 3 o'clock on Friday, and it did not finish downloading the entire blockchain until Tuesday, about 9:30 at night. So it took forever. But I have a whole copy of every transaction that's ever happened on the Bitcoin network, which I can use that to find human traffickers. And I'm going to show you guys an example of just how you can look back. I don't know how to, I probably should have opened this already. Oh. Okay. So this last block was uploaded to the blockchain approximately 3 minutes ago. And it was uploaded by btc.com. So I'm going to show you some actual transactions that have just taken place, and then kind of how we can track it and how that's useful. Oh, it doesn't show the spend stuff. Well, let's just click on it and see where it goes. Alright, so you can see here that this first person sent 0.206791188 of a Bitcoin, and he probably sent it, like he sent it to one of these two. So how it works is, as if I was going to go buy something at a store and it was $1.50 and I give you a $5 bill, you're going to give me my change back, right? So what this does is it spends a larger amount, and then it sends you back what's left over, and then sends whoever you're sending the money to their portion of it. So each transaction actually has 2 transactions. And this doesn't show you. I want to show you a better one. Bear with me. This is actually really cool once you get to see it. Usually they say spent and unspent over here, since it doesn't say that. Ah, here you go. Okay. So they sent this 0.02906696334 of a Bitcoin, and they sent it to these 2 addresses, one of which was probably themselves. And then this person spent the Bitcoin and sent it to these 2. So really what happens is, if we find somebody who's been doing nefarious activities, this really turns out to say, it would, if you thought of it in a different fashion, it could actually say, Kayley just spent this. Because in some way, shape, or form, that's probably attached to my identity. And although you don't know what that means, you can track it back and find who I am, my bank account quite possibly, because it's attached to that Coinbase account if I was to buy that hair color. You can, once you track back to my bank account, you can probably get my house address. you can get the phone number, you can get all that information. So that's why with human traffickers, when they use this stuff, they think they're being real slick, but there's ways we can track them down by associating this address with them or their nefarious activity and tracking it back to them. So most people ask, how does this even work? Because somebody could go back and change it. Instead of saying Kayley sent Bob 10 Bitcoins, it could go back and say, no, Kayley only sent Bob like 4 Bitcoins, so it doesn't set off any alarms on the amount of money. But the way these work is each coin, or each block, is based off the block before it. So they have this thing called a hash that's up here. And so this was the last block that was updated 3 minutes ago that we're looking at. This next one that they're going to post in 7 minutes, this hash is connected from this one. It uses this to compute the new hash. So within 6 of them, you could literally, it's infeasible to go back and change any of those transactions, which is how they can't actually change what they did in the past, which helps us track them down and catch them for their bad actions. So Ethereum and Ether is the coin, it's an altcoin, but Ethereum is the blockchain technology that a gentleman named Vitalik Buterin started working on. He was actually a college dropout in Canada, and he learned about Bitcoin at 17 and then went crazy and has created so much awesome technology in this field. We're still in like the 1990s in terms of like internet. So this is still so infant. It's going to be so awesome once it actually gets out there, expands, and reaches its potential. Smart contracts are kind of smart, kind of not. You could buy a house on the blockchain, and then you have proof that you bought this house. You can't ever change that. And what it is one person says, hey, you have to meet these requirements, and once the other person meets those requirements, the money is paid to the other party. So it's really simple, but supposed to be very smart. Oh, nope, okay, just kidding. So I just will go over again kind of how we use it to track the human traffickers. So you can try to figure out who sent the transaction, who received that transaction. Were they sending a suspicious amount of Bitcoin? So the amounts, and then you can look at things like their bank account, their IP address, their names, their addresses. We only need 3 data points to figure out who you actually are. And people get real tricky and they start creating all these different ports and different ways to send Bitcoin. But for each one of those that are really smart, you have one of us who are also really smart, and our goal is to track you down. So these dogs used to like when they got close to sniff instead of numbers. And since all that seemed like a ton of computer stuff, which I am very, very new at as well, I just wanted to show you guys how this really uses math. So you can break down a Bitcoin into 0.000000001, which is called a Satoshi. So the 100 millionth of a Bitcoin is called a Satoshi, and that's the smallest amount that you can send or receive. And then they use this elliptic curve to make passwords. It seems weird, or the public and private keys, I've read about it a million times, and I can't quite grasp it because it's very, very, very complex. But once they use the X's and the Y's to create these public and private keys, then they use scalar multiplication, and things get crazy. Each Bitcoin is mined by your computer solving complex computational mathematic equations called proof of work, which comes to these, how you can't change it because it's proof that it's already finished and whatnot. And then I tried to take a class on cryptography and learn more about it, but what I really learned is extremely based in discrete mathematics, and it's very complicated. There's a lot of mod this and mod that, and so this is the Silk Road stuff I told you I was going to tell you about real quick. He was known as Dread Pirate Roberts. He was the guy who ran this drug. Well, you could buy drugs, you could buy hitmen, you could probably actually buy humans on his website. And like I said, it was hidden wiki. So he ran this, and he was doing real good. Like, nobody knew who he was until he started getting a little sloppy. And so the FBI ended up going to the San Francisco library. He was logged into his account, and they had two people act like they were like making out, and they snatched his laptop from right in front of him. So they had him logged into his computer, so he couldn't encrypt it. They took his laptop and arrested him, and now he's convicted of money laundering, computer hacking, conspiracy to traffic fraudulent identity documents. You could buy passports. And conspiracy to traffic narcotics. So he actually, we watched a movie on this the other day, he actually hired a hitman to kill 6 different people, but it turns out that that hitman was an undercover FBI agent, and so none of the hits actually took place, but that undercover FBI agent, well, he's DEA agent, he went by the name Knob, and he is actually very important in this as well, because they were going after drug pirate Ross ULBRICHT, and they found out that DEA agent Carl Force had been actually extorting money from the guy who was running this underground website. And so he was extorting bitcoins from him, telling him that he would tell the DEA, FBI, all these people information about him if they found him, and to give him money. He was also the one that he hired to kill people. He was not. Turns out he was extorting money from him. So this lovely gentleman right here, he was smart enough to open a Bitstamp account, and that was a lot of sarcasm because he used an undercover identity to open that Bitstamp account. And somebody at the Bitstamp headquarters was like, there's something suspicious about this guy. You know, something's not right. And he called once and said, hey, will you erase, all my activity because I'm an undercover agent and we don't want people to know what I did. So that raised a red flag. And the guy, I think his last name was Frost, he was one of the workers at Bitstamp. He called what is called FinCEN, the Bureau of Treasury Department, and they look into these financial crimes. So he told that guy, he said, hey, I think something's wrong here. And it turns out that guy was also stealing bitcoins. And now they are both in prison. And the second guy, the FinCEN gentleman, which is Sean Bridges, he opened a Fidelity account and registered it to a company called Quantum Investments, but was dumb enough to use his actual name and his actual home address. So they tracked him down and they found out where he lived and they arrested him too. So that's a little bit about how we can use it to track people down. An example of proof: people stealing Bitcoin, go in prison, and they work federal agents.
So life rarely goes as planned, and don't let go of your dreams because you think there's no other choice. If there's something you're passionate about, stay passionate about it. And this is why you shouldn't settle for anything but your dream. So I was in college, and when I went to college, my parents were dead set, no, you can't be a music major. I was #1 in the county and #2 in the state cello player. I'd been accepted at a university to be a music major, and they said, no, we're not paying for it. So I made the decision, and I said, okay, fine, I'll get a business degree. Then I was hit by a car while I was in college. So I didn't want to do the 5.5 years as an accounting major, so I scaled back to be a finance major because it's basically the same amount of classes, give or take a couple semesters. I felt that I was limited. The year that I graduated college, the state of Florida decided they were going to let go of about 3,000 bank employees. I wanted to go into banking. Well, I guess that wasn't a choice now. So then I decided to do accounts payable work, which is basically about the equivalent of a bookkeeper, very low pay. And of course, in the society at that time, they valued, you got to make money. You got to make money. They didn't worry about whether or not you were fulfilled in your career. So I could do my job. I loved my coworkers. I loved my boss. But I wasn't enthused to get up every morning to go to work. Actually, there were days that I dreaded it. Because, I have all these deadlines and I don't like any of this. So it took me almost 15 years before it occurred to me that I needed to make a career change. When I took that career change, it was because I can translate the IT to the non-IT person, and vice versa. And what I mean by that is I would end up training the IT staff where I worked to understand the needs of the accounting department. You can't do this on this day because we're cutting checks until midnight. You can't run a database update during the middle of the day when we're trying to talk to, we were a student loan company, when you're trying to talk to students. So these were the sorts of things we were training them, but I wasn't being paid to do any of the IT work. The IT guys made 3 times what I made. And I was frustrated. So I decided to go back to school. It took me 10 years to get there. I don't want any of you guys to do that. That was 25 years. 25 years to be doing what I want to do. That's an awful long time. You think 4 years to graduate is an awful long time? 25 years is an awful long time. Find what you like. If necessary, define what you hate. I mean, it really does help. Look for careers that will let you do what you want to do, and then try to figure out how does the math fit. There's many ways I could have gone, but I really like the IT side. Find an employer that will support you as an employee, not one that's interested in the bottom line. Find one that's going to invest in your continuous learning. Once you're done with school, you don't want to stop learning. You want to keep learning. So find a company that's willing to help you pay to get your master's, to get a PhD, take continuing education, whatever it might be. But you never want to lose that. The moment you stop learning, you become stagnant. And then you realize you're miserable, and then it's too late. So we don't ever want anyone to be it's too late. So back to the human trafficking. So how would a criminal communicate on the internet? Other than email, other than on a social media website. How do they hide in what we call hide in plain sight? They have a user, they have a profile, but how are they hiding in plain sight? Once we find one and how they hide, can we replicate that? Is more than one criminal doing that activity on the internet? So how did we start? We started looking for websites that were available to transact business. We were not worried about what was going on in the United States. We knew this was crossing borders between countries. So we didn't need to worry about, what's happening in our neighborhood. But we were looking for patterns. We started out with a classified ads website. We found the pattern. It's this picture. This picture, from the architecture, you can see that's a house that's probably in the United States somewhere. We didn't need to do the lookup of where it was. You can do that with Google or another app. But this, you think, okay, so somebody was selling a car. You can put that on more than one website. This was found on multiple websites, multiple countries, multiple continents. A picture that's from the United States. This is usually how a criminal knows the other criminals out there is truly a criminal, because the picture doesn't fit. But most people scrolling through the pictures and lists of cars that they want to buy don't notice that this doesn't belong in the country that I'm in. So we start machine learning, and we start looking for that continuous pattern. And what we take are, for right now, my current project in the Search for Human Trafficking Network is that we are using support vector machines, which is a lot of math. I don't have a math degree. I feel hindered. I feel lost. The moment my boss starts talking math, the moment she starts talking math, I'm lost. Lambda, wait, I thought that was something that's in AWS. I'm lost. So there's a variety of programming languages that we use, but basically our intention is, this is normal, this is not normal. We want to classify what's not normal. These are the criminals we're looking for. We want to be able to, with a support vector machine, you can draw a line like this, a straight line to identify which side's which. But then I have, right in here, I have too many that are too close together. So I want to try to find, how do I get this definitive line, whether it be a soft wavy line or, so that's what I'm currently looking for. We're going to move into using TensorFlow. But, oh, I'm sorry. Kaylee's going to hand something out to you. Don't flip it over until she tells you to, please. Don't even sneak a peek. It's not worth it. It isn't going to benefit you to do it. Anyway, so we're using a software program called TensorFlow. And it works for multiple applications. It was created by Google. And what Google did was they decided to make this open to the public. They use it for their search engines. They use it for a lot of their email, their spam, to find those patterns so that so you're not having to look at every single spam email. They're pulling it out for you. This application uses that. It uses the Python programming language, and I'm learning Python, and I'm frustrated that I can't get what I want to work. And my boss has said, you can do it. Keep Googling. And I'm like, oh, thank you so much. So anyway, so it's not the only, machine learning is not the only task that TensorFlow does. It handles images absolutely wonderful. So what this does is it takes a support vector machine and they call it, this is one layer of a convolution, and it layers the convolutions and then it decides to turn it back and forth and see what I want to see. So that's how we look for the patterns. And this is what is the big deal for us. How does it use math? We're using math every day, even though I don't know I'm using math. Somebody has to remind me, hey, that's math. Statistics, machine learning, deep learning, graphs, models, algorithms which are designed to implement those statistics. Then we also have the protocols on the wire. So a protocol on the wire, when I say that, I'm talking about the internet. I'm talking about, am I sending, and am I looking for a website? Or am I looking for a peer-to-peer? Am I sharing Bitcoin? Am I BitTorrenting? There's a whole bunch of different, what they call protocols, and it's the type of traffic that's going across the internet. It's a mathematical pattern. And we found a mathematical pattern, but we have to model it so we can present it and say this is what we think is happening. And so with this mathematical pattern, we're looking at, they're called X509 certificates. When I go to a website and it's HTTPS, that's telling me you have to have a secure certificate, and I need to verify you are who you are. There's technology that's in your device that says these are the certificate authorities. The certificate authority has a list, and it goes back and forth. Very complex. I won't even attempt. You guys could probably spin circles around me trying to explain that. You probably could tell me how it works better than I could. Anyway, so those are the mathematical patterns we're looking for. When we can define that that certificate is not a legitimate certificate, because a normal company is going to want their name to be out there. They're going to want their real name, they're going to want their real address, they're going to want their correct URL, because they want to make money. Why would you create a certificate if you don't want money, right? These things are very expensive. So what they do is a lot of companies, especially smaller ones, they self-sign that certificate. And that's normal for people to self-sign a certificate. But that's also what the criminals do. The criminals will take that certificate and they'll put in bogus information. And that bogus information will create their digital footprint on the internet. And that's how we can track them. We're constantly translating everything into and out of binary. These X509 certificates, it would be great if they were human readable. No. They're in base 64 with an ASN1 property. I don't know what any of that means. All I know is I've got to find a computer program that will read that and spit out the human readable format. So we're constantly encoding and decoding the network traffic, which that's the math of cryptography. She probably could do that better than I can. And then we're always creating new forms of analysis. We hope to be writing something very similar to TensorFlow at some point, and we will probably do that before I've been with the company too much longer. And so that's basically how we're trying to find the human traffickers. We're trying to find their digital footprint, because they may have not meant to leave it in the beginning, but there's probably a good chance before they got good at what they were doing, their footprint's out there, and we will find it. Did you tell them how many data points it takes to find someone?
3.
Yes.
3 data points to find somebody's identity. Alright, so this is just a little bit about our focus as a lab, and I'm going to read the politically correct definition off the screen, but I can explain it to you more in, I like the term keep it simple stupid, like the super simple terms, even though none of these are very simple. So at Strange Labs, researchers learn new skills by focusing on applications of mathematics and technology to solve real-world global humanitarian problems, which is why I asked you if you had any in mind earlier, because right now we are detecting and monitoring human traffic networks. So we kind of really nailed that point. I'm sure you guys get this by now. But some of the other things we do is we're doing development of communication systems for academic dissidents. So our boss actually bought a language school, and we are going to create, this is kind of part of this too, I guess, virtual reality foreign language tutorials to keep track of different dialects of languages, just so that in the future, if a dialect of Spanish no longer exists and somebody's using it as like a code, we can go back and find out how it actually works. So we're examining the corporate industrial prison systems, making sure that people are getting what they actually have rights to, like medical supplies. If somebody has a baby, are they getting the accurate treatment, or what happens with that? The UAV sensor development and data collection platforms to track climate change. I honestly don't know much about that, but I just learned about that last night. And then the other one, this one, I love this one. The analysis of satellite imagery to identify delivery paths to provide clean water to civilians. So what we're going to attempt to do is maybe use satellite images of, say, Africa, and make something kind of like Waze, if you guys know, or like Google Maps, basically for it to show us different routes where we could get water to the civilians that are being blocked off and don't have clean water, and things of that nature. So our CEO's main question is, if you could work to solve any problem in the world, no stipulations, you don't have anything like money stopping you, technology, knowledge, what would it be and why? So that is actually what this slip of paper says. And I would like you to flip it over and just give it some thought, give me a serious, real answer. I guess if human trafficking means a lot to you, you can use it, but I really would like you guys to try to come up with something that means a lot to you, specifically, and then what would it be and why would you solve it? And then last but not least, we actually have an opportunity for 2 data science internship positions for you all. It could be part-time or full-time based on your schedule and availability. You get to work with people like myself and Denise and some way more expert individuals as well. And this is the email you would want to write down, just in case you do want to fill out that application and send it in for that chance, because you should. It'll be an awesome opportunity. And then this is Dr. Wunderhead, is that his name? I can't remember his name, but he wants
I'm
to
in the dark ages. I
I
don't have Facebook. This is actually on our Facebook site.
So we're trying to wrangle up our nerds.
And if anyone wants the slides, we've sent them to your professor, so she can share them with you. If you want to be, if you feel like you have a humanitarian problem that we can answer, and you want to be considered for internship, please let Mrs. Dodson know. Also, feel free to put your name and email on the piece of paper. If you want to remain anonymous, that's fine. We have some people that have given us some really great ideas and we don't know who they are, but we're following up on them. Does anyone have any questions?